Everyone, and welcome back to my online teaching platform. You are still on how to determine derivatives of given trigonometric function. This function is a trigonometric function, but you could say that it is a fraction. It involves a fraction. So we consider it as a rational function where the denominator of the given function is not equal to 0. Looking at this form of function, the best rule that will help us differentiate the function is the quotient rule. So let us start with. So function, our solution is here. So our function, which is y, is equal to sine x plus cos x divided by sine x minus cos x. So we compare it with the fraction u divided by v. So our u will be the numerator, which is sine x plus cos x. Then you find the derivative of the function. So we are going to differentiate function u with respect to x. So let us look at it. When you differentiate sine x, we are going to get cos x. When you differentiate cos x, we are going to get negative sine x. Let us take the other part, which is the v. Our v will be equal to sine x minus cos x. Now let us differentiate our v with respect to x. So dv dx. When you differentiate this sine x, you are going to get it as cos x. When you differentiate your cos x, you are going to get negative sine x, but we already have negative here. So it's going to be plus sine x. All right. So let us now bring our formula. We have a formula to be dy dx equal to v multiplying du dx minus u multiplying dv dx, all divided by v squared. All right, so we are going to substitute the various components of the formula here. So we know our v to be sine x. We know our v to be sine x minus cos x. Then we know our du dx to be, okay, is here to be cos x, minus sine x. Then minus our u, the original u. So the u itself is sine x plus cos x. And this will also multiply the dv dx. So our dv dx is cos x plus sine x. Okay, plus sine x. Then we divide everything by the denominator. So the denominator is the v. So our v, we know it to be sine x minus cos x. So you just take a square of it, v square. So you have to square it. So let us work on this. There should be a bracket here because this is a binomial. The terms are two. So we are going to expand the bracket. So we have sine x will multiply cos x and negative sine x. So sine x cos x will give us sine x. Let me bring the equal to sine. So we have sine x cos x. Then sine x multiplying sine x will give us negative sine x squared. Then negative cos x multiplying positive cos x will give us negative cos x squared. Then negative cos x multiply negative sin x will be as positive sin x cos x. All right. Then you divide it by, sorry, minus, yeah, you have to work on this part. So here to sin x will multiply cos x and sin x here. When you are done, you use the cos x also to multiply cos x and the sin x. So sin x times cos x gives cos x. Let me bring the sign first. They are all the same, but let me bring the sign. So sin x cos x, okay. Then sin x times sin x will give us sin x squared. Then cos x times cos x will give us cos x squared. Then we have cos x times sin x giving us sin x cos x. Close it nicely. Then you divide it by the denominator squared. Okay, so we have it as sin x minus cos x in bracket squared. So let us continue to simplify. We have cos x sin x. And we also have, so we have cos x sin x, then another one also here. So we are going to get two of them. Yes, we are going to get two of them. So it's going to be 2 sin x cos x. Then we are left with minus sin x squared minus cos x squared. Then minus bracket of, let us see if yet we have like terms. Yet we have like terms. We have cos sin x cos x, then yet we have sin x cos x. So we have 2 sin x, then cos x. Alright. So we have 2 sin x cos x. Okay. Then you now have plus sin x squared, then plus cos x squared. Close it nicely. All divided by sin x minus cos x, all in bracket squared. So this, we have 2 cos x sin x, because we have minus here, so minus 2 sin x cos x. Okay, then let us see if here too, here we cannot, so let us now repeat our next step. Our next step will now be negative sin square x minus cos square or sin cos x squared, then minus this negative one will multiply the sin x squared. So we are going to get minus sin x squared. The negative also multiplies plus positive cos x squared. So we are going to get negative cos x squared. Then all divided by sin x minus cos x in bracket squared. So let us work on the numerator. Okay, beside the numerator, we have something in common. Yes, we have negative sin x squared, then another negative sign. So we have negative 2 sin x squared. Then we have negative cos x squared minus cos x squared. So negative 2 cos x what squared. All divided by sin x minus cos x, all in bracket squared. So we can now factorize negative 2 out. So we factorize negative. So we have -2 out, because -2 is common to the two terms in the numerator. So we have sine x squared plus cos x squared. Okay. Then divided by sine x minus cos x or square. Let us continue. Now we have an identity in trigonometry that anytime I have sine, let me write it somewhere. Anytime I have sine x squared plus cos x squared, the sum of the two ratios must be equal to 1. So sine x squared plus cos x squared must be equal to 1. So we are going to use it to replace the sine x squared plus cos x squared in the bracket of the numerator. So we have -2 will now multiply 1, because 1 is the same as sine x squared plus cos x squared divided by sine x minus cos x, or in bracket squared. Okay. So we conclude that our dy dx is equal to -2 divided by sine x minus cos x, or in bracket having an exponent of 2. Thank you for watching. We'll be dealing with more examples in our subsequent videos, but please do not forget to subscribe to my YouTube channel. You can equally share with others to also subscribe. So in our next lesson, we'll be looking at application of differentiation in real life. So we'll look at real world application of differentiation, how we can apply differentiation in real world situation. Bye.